Okay, so probably I will start the lecture now. Just want to let you know that the lecture is recorded. I will stop the music for a moment. Okay, alright. Here we go. Hi, good morning everyone. My name is Dr. Kla Tantitham Thawan. So welcome everyone to FIT 5136 Software Engineering. This is the first week of this unit, and today we're going to talk about what is about this unit and how do we run the unit. Okay. Next slide. Yep. This is the teaching staff. Myself, I'm a senior lecturer in software engineering. I'm also the chief examiner and also the lecturer for the next 12 weeks as well. Within this unit, we have roughly 260 students. And then we also have a number of applied sessions that every student need to attend as well, and that's why we have these following tutors as well. We have Dr. Sarah, Mersamomen, Max, and then Wanita. And then actually we're gonna have one more tutor as well, but we are recruiting at the moment. Okay, and within this unit, right, software engineering is really important. Right now, I think everyone use the digital application every day. But the key question is that how can we develop high quality software system? And within this unit, these are the unit learning outcome that every student need to achieve. First of all, I expect that everyone will be able to understand what is a software development life cycle, different phase, different steps within the cycle as well, starting from the requirement engineering, software design, software implementation, software testing, deployment, and the maintenance as well. Okay, and during the requirement engineering, right, we need to understand the structure of the software, design the software diagram as well. So this is what we need to do as well. And then everyone need to implement the software system using the object-oriented principles as well. And then you will also learn how to apply software testing, how to implement the unit testing, different types of the software testing technique to ensure that the code that you develop is actually functionally correct. Okay, and because we work in a software team, right? No, so we work in a software project. We need to work as a team. We never work in silos. So I think the key question is that how can we effectively work and communicate in the team-based projects as well. And also, the most important thing, we will teach you about how to make sure that the software that you develop is actually ethically aligned with the principles as well. How can we identify the ethical issues? How can we handle issues kind of like intellectual property, privacy, security, that kind of thing. Okay? Okay. So to achieve this unit learning outcome, right, we design the unit to follow the Agile Scrum project management. Basically, we split the learning content into 5 modules. Okay, the first one we will talk about the introduction to software engineering, which is the first week, and then we're going to talk about different types of the software development processes, and then we're gonna start we want to make sure that students adopt the Agile Scrum project management. So we're gonna give the lecture content following the process, starting from the requirement engineering, project management, development, and the testing. During the requirement engineering, you will learn how to gather the requirement, how to you will act as a product owner, talk to the client, gather the requirement, elicit the requirement, analyze the requirement, whether that how can we translate the requirement which is not clear and structured into a more structured requirement, and we can write in a user story format. And then we're gonna talk about how can we estimate the task, prioritize the task as part of the project management as well. And then we're gonna learn how to design the class diagram, write the use case scenarios, decide create the state chart diagram, and that kind of thing. And then we're gonna develop the software, and then how can we work collaboratively together. We will talk about the sprint as well. What is how can we run the daily stand-up meeting, sprint review, how can we do the sprint retrospective, and what exactly is the agile. We will, what is the manifesto, what is the values in that as well. Okay, and the most importantly, we will talk about the software testing. Okay, so to achieve that, right, we design the unit structure like this. We have 12 lectures content starting from introduction to software engineering, requirement analysis, agile project management. We will have 2 lectures about software design and modeling, and then we'll talk about software quality and testing. What is the quality assurance activities? How can we write the unit testing? How can we measure whether the testing that we apply, that we run, is actually effective or not using the code coverage? And after we do lots of software testing, we need to do code review as well within the pull request, merge request, that kind of thing. What is the code review process, right? And there are different types of the software testing technique as well, like black box and the white box. We'll talk about that as well. How can we generate the test cases, that kind of thing. How can we decide the test case and ethics, which will be teach in week 10, and then we'll talk about software deployment and the DevOps. And last but not least, the week 12, it will be about the advanced topic. Okay. For those who join us, could you please mute yourself as well? Thank you. Yeah. And based on these 12 lectures, we decide to have 4 assessments, okay? And these 4 assessments, basically, it is aligned with the software development process anyway. We'll start from the requirement gathering and analysis, okay? That's the first assignment. We'll work as a group. It is with 15%. It will be released by week 1 or week 2, and then it is due by week 4. For the second assessment, it will be about software design. Okay, software design. It is also based on it is work as a group as well. Everyone need to submit as a group work, and it is weighted 15%. And then, so actually one thing that I forget to mention is that for the assessment 1, 2, 3, it is under one project scenario. Okay, that we will give you one informal requirement. Student need to elicit the requirement, decide the class diagram, decide the use case scenarios, that kind of thing, and then you will need to develop the software. Okay, which will be part of the assessment 3. For the assessment 3, we will look into the code, look into the process, how effective you apply the agile within the team as well. And then we will, for the assessment 3, everyone need to complete everything by week 11, and we will have the presentation by the week 12. Okay, so for the week 12, everyone needs to give the presentation about the software that you develop. And basically for the software, it will be a lightweight one. We just expect you to implement just a text-based program. You can use either Java or Python. You don't need to develop like a crazy, extremely well-designed the desktop application, that kind of thing, or the web. Okay, we don't need that. And then for the assessment 4, it will be an individual component, which is about software quality and testing. We will talk about that later as well. But basically, everyone need to write the unit test, write the code, and make sure that you achieve 100% code coverage. Yeah, the detail will be provided later as well. So for the assessment 4, it will be released around week 9, and then we expect that everyone should complete by the week 14, and probably we can finalize the unit by the week 15. Okay, any questions so far? Anyone? Yes, that's a good question. So we have one question about the exam. Basically, this unit has no exam. Last year there was an exam, but this year we don't have. Okay. Do we have to choose our own team? Yes, student, we will provide more details later as well, but basically the principle is that every student should form a team within the same applied session. So that means for the first week of your applied session that you have been allocated, I highly recommend you attend it and try to create the group by yourself. The details will be provided in the Moodle as well, in the eDistant. Okay, what programming languages are we allowed to use for this unit? We allowed to use either Python or Java. I think we're gonna talk about that in the next few slides. Okay, maybe I'll continue and then I will come back to your questions again. Okay, so for this unit, right, we run over the 12 weeks, and basically we have for each week we have one online lecture which lasts 2 hours. Okay, 2-hour lectures for each week, and it will be online only. Everyone need to attend on Zoom, and for each week we also have the applied session as well, 2 hours. I recommend everyone to attend as well. So roughly for the whole week, you probably need 12 hours to work on this unit. Okay. In terms of the cheating and plagiarism, this is very important. Surprisingly, I have been involved in this unit for 5 years already. And then I have seen lots of plagiarism and cases happen every year. I highly recommend please be mindful about this, because when you do the work that is not authentically from yourself, you may be encountered with the plagiarism issues. And whenever this kind of case happen or detected by the tutors, then we need to submit the plagiarism case to the university, and then the university will decide whether what is the penalty that you are going to get. For example, right, it could be a 0 mark for that assessment, or a 0 mark for the whole unit as well, or you may have a suspension for the course, or you have been excluded from the university as well. So there are lots of various penalties that could be applied if this is the case. So, but the most important is that the outcome will be recorded and kept within the university for 7 years, right? So I think it will be impacted to your CV as well. I highly recommend that you should try to contribute yourself to the unit. Make sure that the work that you do, the work that you submit is authentic. It is the work that you created by yourself, not by someone else. Okay, makes sense? All right, I'm aware that within this age, right, we have generative AI, we have ChatGPT. So we actually encourage everyone to use ChatGPT as part of the learning process. However, based on what I have been experienced so far is that ChatGPT may not provide the right answer every time, right? Sometimes it is correct, sometimes it's not correct. So at the end of the day, it can be your learning assistant, but you should not like solely rely on the answers provided by the ChatGPT. Okay. And another thing is that if you want to use ChatGPT to help in your programming assignment, there's a higher chance that ChatGPT will produce the same program for every student as well, which also leading to the higher chance of the plagiarism cases as well. So again, I think I would say that you can use, but you should be aware that what are the negative consequences that may happen to you as well. Okay. All right. Yeah. And this is the question. The answer to one of your question as well about what is the preferred programming languages to be allowed to use in the unit, right? Because OOP, object-oriented programming, is part of the unit learning outcome. So that's why we encourage students to use either Java or Python. And yeah, I just want to understand your background as well before we move on. Maybe you can type in the Zoom chat which programming language that you are most proficient at the moment, Java or Python. Yeah, can you type in the Zoom chat? Yeah. Just want to hear. Okay, yeah, Java or Python. Yeah, cool. Okay, that's good. Thank you. Thank you, everyone. Wow, 147 students. Okay, cool. All right. I think there are a few things that I need to cover as well. So within this unit, right, we will use various tools as well. We need to work as a team. So that's why we're going to use Trello as part of the project planning and project scheduling, task prioritization, that kind of thing. We also use GitLab for code collaboration as well, and the faculty will provide this one for you, so you don't need to use the individual GitLab account. We need to use the GitLab server that is hosted by the faculty. Okay, and then we're gonna use Lucidchart for drawing the diagrams. It can be a class diagram, use case scenarios, state chart diagram, that kind of thing. Okay, yep. And then normally you can use Google Drive for storage as well, to store the documentation. We'll use the feedback fruit for evaluation, for the peer evaluation as well. Yep. Okay, FYI, just want to emphasize to everyone, the learning resources will be available at EdSTEM only. Okay, different from the other units. Some other unit they use Moodle mainly, but for this unit we're going to use the EdSTEM. Please don't send me an email, hey Dr. Kla, I go to the Moodle where I cannot find anything. Okay, I already emphasized that everything is in the EdSTEM. Okay, the learning materials, video recording, tutorials and everything in EdSTEM. But for the submission, for the assessment 1, 2, 3, every student need to submit in Moodle, but for the assessment 4 we will use EdSTEM again. Okay, make sense everyone? Clear? Yeah, so one question, a recording will be up after 24 to 48 hours anyway, so I think you are good. Yep, thank you. That's right. So I try to be active within this unit as well. So I will keep the materials up to date. I have an issue with my enrollment where all the time slots are full for the applied learning class. For week 1, would it be fine to drop into any other? Yes. Do the group need to be based on the time slot that we enroll? Actually, for the first week, it is true that the group need to be based on the time slot that you are enrolled. So that's the mandatory requirement. But for the first week, if you cannot enroll anything, you feel free to drop into any other class. Yeah, that's totally fine. Yeah. All right. Yep. Thank you. And just want to make sure that everyone have access to the EdSTEM. Is that right? Yep, so that's the EdSTEM. If you haven't seen the welcome video, feel free to watch as well. And this is the lecture slide. Once we finish this lecture slide, you are welcome to watch. This is a case study with Monash eSolution as well. Cliff is the director, associate director at the Monash eSolution in one of the department. You can learn from him how the waterfall works in 20 or 30 years ago. What is the agile transformation process and how does it work at the moment? Okay. All right. Next. Okay. Yep. Any other questions? We talk a bit about ChatGPT, but what about other tools such as Copilot? I have never used it before, but I'm thinking of getting a subscription. Yes, you are. Yeah. I don't mind if you want to use the Copilot as well, to be honest. But at the end of the day, you should be mindful that about the code that is generated by the Copilot or the generative AI tools, right? Whether it is going to be the same for the other student or not, yeah, that's a risk, yeah. So I cannot guarantee about that. Okay. We will be having interviews for all of our assignment. The details will be provided later. Yeah. Some of them, yes, there are. Yeah. At least I think at the moment for the assessment 1, there will be a presentation on week 5. For the assessment 3, there will be a presentation on the week 12. So please make sure that you attend your apply session for both week 5 and the week 12. Yeah, it is mandatory. Okay. Any other questions? All good. I think all good. I don't see any questions in the Zoom chat now. Maybe I will start the lecture. Okay, so yeah, as everyone know, right? Right now we are in the digital world. We are experiencing the digital transformation, and software right now actually impact every industry, not just software industry, but also the e-commerce, the online banking, telemedicine, healthcare, and everything. Right now we try to shift the technology from the traditional style to the more more innovative, more smart, using data, AI, IoT, automation, or that kind of thing. Yeah. So that's why software engineering right now is very, very important. But let's take a look at the different domain and different industry, right? So what kind of software that they are using at the moment? For example, in the healthcare sector, they normally use the electronic health record system, right, to provide to record the patient records, that kind of thing. And then that means the doctor can look into the patient information, medical history, treatment plans, that kind of thing. That's what happened in the healthcare system, healthcare sector. For the financial sector, of course, we now using the mobile app banking, the bank, online bank, okay, application where we can use the online bank application to access the to do the withdrawal, money deposit, transfer, that kind of thing, pay, do the grocery online shopping, that kind of thing. So that's the software in the financial sector. And the same thing for the e-commerce and transport and the education sector, right? So what I mean is that software is everywhere, but the key question here is that how can we develop high quality software system that meet the need and the requirement of the user, stakeholder, and the organization at the lowest cost as well? Because in real world scenarios, we have limited budget. We cannot just develop one piece of software for 10 years, right? So that's why we need software engineering. And basically engineering, software engineering is an engineering discipline. We want to apply the engineering principles to the software development as much as possible. When we talk about computer programming, software development, we just focus on how can we develop the software, but we didn't engineer the piece of software, right? When we talk about the software engineering, we want to optimize the process to make sure that we can deliver the software products at the highest quality within the budget constraint as well. Okay, so back to 1963, that's the first time that software engineering was first coined by Margaret Hamilton. So she is a computer scientist at the NASA. She worked for NASA. At that time, she was a computer scientist and a system engineer as well, focusing on the NASA Apollo mission, right? And then at that time, when she worked on the piece of software at NASA, she just felt that we should apply the term software engineer to the work that she do. Yeah, so it's not just only computer scientist. Okay, so she feel that whatever she do at that time, it was much of the engineering rather than something else. And it is engineering same as the Apollo spacecraft as well. So that's why she coined the term software engineering at that time. And she felt that software engineering is actually more than just computer programming as well. And if and one of the questions that most of the students ask is that, so what is the difference between computer science and the software engineering, right? So from my point of view, I just feel that computer science actually focus on the theory, the fundamentals, data structure, algorithms, how can we optimize the code, okay? But it doesn't mean that software engineering, it doesn't mean that the code that is optimized by the algorithm or the data structure is actually useful or meet the client requirements. So that's why software engineering is about how can we develop the piece of software that is actually useful to the clients. All right. Yes, the Zoom is recording at the moment. Yeah. Okay, but to develop the piece of software, it is very difficult. It's not that easy at all. And most of the time, what you have seen is that there's a bug, you know, and it is very frustrated. Have anyone seen like a bug in real life before? Can you type in the Zoom chat? Like, what do you think? Yeah. I'll just keep talking about this one. Okay, so this is these are the two examples, right? When there's two examples of the software engineering failures. So in the past few years, everyone have used MyKi before, which is the Melbourne Metro system, right, for Victoria. And to develop this MyKi system, right, they said it took like 7 years more than what they have planned. So that's a overrun project already, right? And they said they spent 55% more than the budget. So what does it mean? It was budget for 1 billion, right? But at the end of the day, at the end of the project, they spent roughly $1.5 billion. So there's a huge overrun, cost overrun over budget, right? And what is the problem? Because they found that there's an unclear divisions of the responsibility, lack of expertise, scope creep, as well as the poor working relationship between the contractor and the transport authority, right? And at the end, when they deploy the system, it has a glitch as well. So it's not really perfect. It's not fully test, that kind of thing. It's not reliable. And it impacts the end users like us, right? So that's why software engineering is very important. How can we optimize this kind of process and make sure that we develop the software efficiently and reliably? Okay. Yeah. Okay. Yep. So then when we talk about this is like the negative consequence, right? When the software product is failed, then what makes a good software? There are different attributes of the characteristics of the good software system as well. For example, the software system should be highly maintainable. Of course, when we develop piece of software, it's not just like one go, you know. We develop 1 year, but we may need to maintain for another 4 years to make sure that it has a 5-year lifetime, that kind of thing, okay? The software should be dependable, and it should be highly secure. Right now, as you have seen in the headline news, right? What is that? Personal information was leakage, was stolen via the Medibank, Optus, that kind of thing. That's about the security issues. And then the key question is that how can we prevent such kind of security issues as much as possible as well? We don't want this kind of issues to happen because it causes frustration to the end users, right? To the customer. Yeah. Efficiency is the good thing, is the one of the key important characteristics of the software system as well. What if the software is not responsive at all, right? When you access the website, it took like 5 minutes to respond. If you want to do some ATM transaction, it took like 5 minutes to respond. So it's not responsive, it's not efficient. Then the key question is that how can we handle this as well, okay? Yeah. And when we develop the software, it's not just like the software is functionally correct. We need to make sure that the software meets the customer requirement as well. It is acceptable. So normally we need to do the acceptance testing. Okay, all right. That's part of the software engineering process. Okay, but the key question is that what is software engineering about? Okay, this is the simplest form that to visualize what the software engineering is, and I feel that we can call it PPT. Okay, it is people, process, and the technology. This is the software engineering. It's not just only the process. It's not only the people. It's not only about the technology, but it is everything combined together to make sure that everything is excellent, right? When we talk about the people, when we develop a piece of software, there are multiple stakeholders. It's not just only the software developers or the clients, but we need to talk about who are the stakeholders within the team as well. There are different stakeholders, not just the software engineer, but what about the site reliability engineer, the infrastructure engineer, or the business people, the law. We need to handle that kind of thing as well. Okay. There are different types of the process that when we develop piece of software that people can choose. Okay. For example, agile or waterfall. And in terms of the technologies, right now there are lots of technologies that we can choose. If you use the wrong one, then it may slow down the process, right? Right now we have lots of intelligent IDE like VS Code, PyCharm, IntelliJ. But what if we just use like 20 years ago, Notepad to write the code? Probably it's not that efficient at all. Okay, that kind of thing. Okay, so when we talk about the process, right, it stands for a set of the structure of the activities that are required to develop a piece of software. Okay, and normally we can break it down into 4 steps here. The first one is that is the requirement and analysis, right? We don't know what we need to develop until we know what is the specification of the software system. Okay, so the spec will define what the system should do, how the system should look like, what is the functional requirement, what is the non-functional requirement, how the UI looks like, that kind of thing. If the developers don't know any of the requirement, they have no idea how to design and implement. Okay, so once they know the requirement and they analyze the requirement already, these are the features that they need to develop, then they can decide how the class should look like. These are the class about the customer, these are the class about payment or whatever, the catalog. Let's say this is an online shopping system, right? So yeah, so once they design and they implement it, then we need to verify and validate the software system as well, whether whatever we develop is actually correct or not, right? Let's say, let's give one example. Let's say we are developing an online shopping system. We have a discount campaign. What if the code structure around the discount was wrong, right? So the business owner can lose like millions of dollars as well. Okay, that's an example. So that's why we need to verify the code as well, whether it is correct or not based on the given requirement. And then it's not just only develop the piece of software and then all done, right? We need to make sure that the software is well designed, it is easily to maintain, and it can be evolved over time as well. Just for example, this is like what happened in real world scenarios, right? Requirement change every day. If we develop today, what if tomorrow the requirement change? Can we easily extend the code, or do we need to implement everything from scratch again? So it's too expensive, right? So that's why if we design the class really well, everything is well designed, it will be easy to maintain as well. All right, and all of these, right? All of these factors and the constraint, everything is based on the effort and the cost, because the effort and the cost is limited. We have a limited budget. We cannot develop the piece of software for 10 years. And normally as you can see, the bad software normally works only one time. And it is a waste of resource, right? If you develop one piece of software, it can be used only 1 or 2 days and then all done. It is really costly, because when we develop software, it consists of many people in the team. Let's say 5 people, okay? And then let's say each person has a salary of 100K. So one piece of software actually costs 500K already, and if it works only one time, it's too costly. Okay. And then good software, what does it mean, right? It means that it can be evolved over time. It is easily to maintain for 10 or 20 years. And if there is any change in the requirement, yeah, we can handle that as well easily. Change in the technology, database change the database technology change every 10 years, okay? In the past, we often use MySQL, MySQL, but now we talk about the NoSQL already, yeah? And right now, right, as you can see, as I mentioned about the cost, the majority of the cost is actually goes into the changing the software after it has gone into use. It is very costly because no one worked within the team for 10 or 20 years. There's people come and go as well, right? So if the software is not easily maintained, the new people who join the team may not be able to extend it as well. So that's why the effort and the cost are the most important factors when we develop the piece of software. All right. Yeah, and I think that there's one more point as well that I really want to mention is that the cost of the software is actually greater than the hardware cost. Let's think about one team, right? Consists of 5 people and it costs 500K to develop the piece of software. But when we deploy the software, it may actually cost a few $1,000s. Let's say if you deploy on the cloud, Amazon or the Microsoft Azure, that kind of thing. Okay, so that's why we need to consider about this aspect really well, and everything is concerned about cost-effective software development. Okay, yep. So how can we make sure that the software development process is cost effective, right? So that's why in the past people create different types of the process, different types of the life cycle models that right now we can use, okay? And the traditional process is called waterfall, okay? And then I'm gonna talk about that in the next slide. Waterfall, basically it is a plan-driven process, and we normally start from the requirement. We elicit the requirement from the client, and then we need to analyze the requirement, what it is supposed to do. And normally when we elicit the requirement, right, most of the time clients don't know what they want. That's what happens in real world, okay? I want to, let's say I'm a CEO, someone interview me, try to elicit the requirement. I want an online shopping application, something that can actually increase the profit of the company by 20%. That's the requirement from the CEO. But this is the business requirement, right? This is the business goal. We want to increase the sales by 20%. And then when we talk to the technical team, delve down into the technical requirement, that kind of thing, then we need to decide a little bit more, like what it is supposed to do, how it should look like, how can we develop a campaign to increase the sales profit, that kind of thing, okay? So we start from the requirement analysis and then we design. When we know these are the interaction, these are the features of the software, then how the class, how the object will interact with each other, that kind of thing. And then the team can start do the implementation and then repair and then retire. Retire means deliver the software. Okay, so it is really plan driven. But what happened is that normally requirement analysis, requirement gathering often takes time. It could be a year, right? And it is very challenging in real world scenarios. We cannot elicit the requirement for 1 year because technology change every day, right? So that's why what is that? And another thing is that there's a moving target problem as well. For example, today we want to work on something. This is a requirement, but tomorrow problem change. Everything change. Requirement also change as well. So how can we handle this, right? That's why people create a new how can I say, another process model. It's called what about waterfall with the feedback, right? Let's say once we do the requirement, okay, we do the analysis, okay, requirement, do the analysis, and then decide implementation, post delivery, maintenance, and then we try to get the feedback from the clients. Okay, so the feedback will go back to here, to here, to here, and maybe we can start everything again from scratch, right? But still, it is too expensive, right? Because once the requirement is finished, analysis is done already. If we need to change, if the requirement change, we need to change the design, implementation, and everything. And it is too costly. So that's why we should. This process model is still not really effective in real world scenarios. All right. And there are some problems here, right? It's about problem with the written specification. Waterfall really focus on the documentation. They may spend 1 year to write the requirement specification document, and they need to, how can I say, they need to write lots of technical documents. For example, UML diagrams, class diagram, everything is well designed, and then 1 year after the requirement change, nothing works again. Okay, so and another issue is about the communication as well. Client may not be able to wait, let's say 1 year to see the final product, right? So they want to see the working products every sprint, every week, every month, that kind of thing, to ensure that we are on the right track. Okay, so that's why waterfall is not that really effective for nowadays. Okay, and what I want to mention a little bit more is that software engineering is very different from the traditional engineering, right? When we build a house, normally we need to make sure that how the house look like. We have the concrete specification. It has 2 stories, it has 4 bedrooms, 2 bathrooms, 2 garage, 2 cars for the garage or whatever, right? So we for that kind of engineering, we need a concrete requirement. But for software engineering, it is really abstract, right? When we want to build a piece of software, let's say online shopping application, what is that? How does it application look like? So software is really abstract and flexible, and there are 2 challenges. Okay, the first one, again, I mentioned like many times already, is all about the requirement. Frequently, customer don't know what they want, and the feature space is infinite, right? What I mean is that as a CEO, I want to increase the sales profits by 20%. I don't know what the feature should be. You need to think about that. Okay, so they talk to the consultant, business analyst. They need to come up with the feature, and then they may come up with, let's say, 100 features. That's a lot, right? But then again, we need to release the app by next month. We have only 1 month to develop the piece of software, the application. How can we prioritize it? Which feature that we need to develop? So we have the time constraint. Everything is a time pressure. Okay. Yeah, and we cannot do 1 year gathering the requirement. We cannot do 1 year designing the system, that kind of thing. When the software becomes ready, it may be obsolete already. Okay. And in the past, waterfall really focused on the detailed documentation. This is like traditional engineering disciplines, right? They really focus on the documentation, define the terms and the definition. These are the things that we need to consider. These are the requirement, the features, what is the goal, what is the product vision, the roadmap, that kind of thing. It takes too long. We haven't started develop anything. We just spend most of the time on the requirement analysis, gathering the requirement, develop the product vision, design. It's all about planning, not doing. Okay, so that's the 2 challenge of the the waterfall model. That's why within this age, right, there's another model people call rapid prototyping. Okay, life cycle model. So what does it mean is that rather than focusing on the documentation, we focus on the prototype instead. We want to create the proof of concept. We want to create the digital prototype, and a prototype means it is an initial version of the software system. the concept design. This is the idea, UI, rough mock-up UI. This is how the system will look like at the end, but it's not the real implementation yet, okay? It's just a mock-up. This is one approach that we can do as well. As part of the requirement gathering, right? We use the prototype, okay? And then once you have the prototype, right, it is quite of it is more like a client oriented. You interact with the clients, talk to the customer rather than development team. So it requires more interaction. Okay. Yep. Okay. And when we do the rapid prototyping, right, normally we start with the prototype, discuss with the customer to do the review the prototype that we have at the moment, whether we are on the right direction or not. Is this something that we are looking for? And then we can refine and iterate over time, right? Okay. Once the prototype is clear, then we can start design the software, design the application, design the class, design the system, and then start the development. Okay, make sense? But is that the solution to everything or not? Okay, is that the solution to everything? Yeah. Probably not, right? Because when we do the rapid prototyping, we didn't do much of the documentation as well. It may cause some issues when we handle about the payment, the cost of the software development, that kind of thing. For example, right? When we sign the contract and then let's say we're gonna use the rapid prototyping. We sign a contract for 100K already to develop the piece of software, but we still keep design the prototype, keep designing the prototype every day, iterate, refine, and it's not clear when we are going to stop, right? So at the end of the day, prototype can be one part of the activity as in the contract as well when we work in real world scenarios. So, okay, that means rapid prototyping is not the sole thing. It should be part of the activity when during doing the requirement engineering. Okay, this is another one, incremental development. Okay, before we move on, any questions so far? Let's take a break a little bit. Any questions? Yeah. Am I going too fast or not? What do you think? Okay. Okay, good pace. Thank you. All right. What to do if the clients were to make some unreasonable demand for the software? Very good question, right? So, I think this is normal, but I would say that we need to communicate clearly and constructively to the client as well. Probably before we develop any piece of software, we already set the timeline within the contract. Let's say if I were you, I would just say, hi customer, as we have written in the contract, right? We have only 1 year period to develop the piece of software. I'm afraid that this kind of features may not be, we may not be able to deliver this kind of features within the timeline constraint. What about we try to prioritize what are the must-have feature, what are the should-have feature? Okay, that kind of thing, or some features that we don't really need at all. So that's why we need to prioritize what are the need and what is needed, what is not needed. Okay, we'll talk about the task prioritization in the next few weeks as well. Okay, how will we understand that which development methodology should use? That's right. So I would say that mainly there will be two main approach, waterfall or agile anyway, or I would say that incremental development as well. Anything is okay, but I think the key question is that it depends on the requirement. It depends on the nature of the software system that we develop, whether the requirement is clear or not. For example, if we know that this is something that we are going to develop right here, right now, and the spec is really clear, we can just use the waterfall model or the incremental development as well, right? But when something is not clear, I want to develop an online application. We want to develop a game. What kind of game? We don't know. We need to think, we need to design, right? So during the design concept, that kind of thing, it's more like we need to adopt the agile approach because we are not clear yet what we are going to develop. So that's why we need to use the sprint approach to deliver the working products over the documentation, that kind of thing. I should talk about the agile. Should talk about the agile in the next few slides as well. Okay. All right, maybe I will continue. Thank you so much for your questions. I really love it. Okay. Incremental, yeah, is one more question. Is rapid prototype is one of the agile methodology? I would say yes, partly. I would say rapid prototype should be called as a activity. Okay, it can be used as part of the agile methodology as well. Methodology is the process and the framework. During the sprint, we can use rapid prototyping to design the UI and communicate with the customer. Okay, does it make sense? Yeah. Sounds like everyone understand what agile is already. Okay, I'm gonna move on. Incremental development. Okay, so incremental development, it is similar to the waterfall, but it is still there are some part that is different. Okay, because for the incremental development, let's say we have the outline description already here, and then that means the requirement is clear already, right? No, not clear. Okay, we have the informal requirement from the customer, but then during the specification, the requirement here, development and the validation, we work as a incremental, as a iteration. You know, we work as an iteration, and during the specification, we can. During the first iteration, we can deliver the initial version, intermediate version, and the final version as well. So it's kind of like similar to the agile, but not technically agile. Okay, yeah. So yeah, the key point here is that each increment includes some of the functionality requested by the client. So we incrementally deliver some piece of software to the client. Okay, that's the incremental development. We transform the waterfall into the mini waterfall as a iteration. Yeah, that's an incremental development. Okay. Another question: in a situation, developer using waterfall model in the middle of the project, customer asks to change some of the feature. What will be the situation and the outcome? If that happens, right? So then we need to go back to the requirement engineering again. But it cannot be happen in real world. So what I mean is that waterfall, incremental development, agile, they are only in the book. It's not in real world. In real world, it depends on the negotiation skill between the project manager and the customer, right? Whether we're gonna accept that requirement change or not. Okay. Yep. So next, for the incremental development, there are some benefits and there's a pros and cons as well. In terms of the benefit, right? We can reduce the cost when we want to accommodating the change in the requirement as well. It is easier to get the client feedback, right? Because we work in as an increment. Where for the first increment, after everything is finished, finish the spec development and the validation, we can release the initial version to the customer, that kind of thing. Okay, and then we can rapidly deliver and deploy the software that is more useful to the customer as well. It increases the success rate. Okay, mitigate the risk as well. However, when there's a cons for the incremental software development as well, what they found is that the process is not visible, right? Managers need regular deliverables to measure the progress. If systems are developed quickly, it is not cost effective to produce documents that reflect every version of the system, because we gradually change everything. We release quite often. We need to work on updating the specification again and again and again, right? So That's a con, okay? System structure tend to degrade as new increments are added, unless time and money is spent on refactoring to improve the software. So regular change tends to corrupt its structure. Incorporating further software change become increasingly difficult and costly as well. So it's one approach, but not the ideal yet, okay? That's why we have the agile methodology. And agile methodology is actually designed based on the incremental software development as well. And agile appears in the late 1990s to reduce the delivery time for the working software system, right? It is quite suitable for the clients who don't know the system specification yet, all right? And they feel that for the agile methodology, rapid development and the delivery is very essential. They focus on the software delivery. They don't focus on the documentation. Okay, they focus on how can we deliver the software quickly. Yeah, so that's why they adopt the incremental software development. It is quite similar to what we what we have learned in the previous slide, and the documentation is very minimal. Okay, if you look at the figure here, normally we will start from the step 1, right? We define what are we going to do within the sprint. We design, we develop, and then do the demo to the customer as well. Keep it like this as an iteration, okay? Then you can get feedback from the customer, from the client as well, and then by the end of the next few sprint, then you can release the software that customer want. Yeah, okay. All right. So when we talk about the agile, we should understand what is the agile manifesto as well. Basically, there are 4 principles here. Okay, they focus on the individual and interactions over the processes and the tools. Okay, they don't focus on the what is the next step. What are we this is the for the when we use this process, we are in this step, we cannot do something else, we need to focus on this. Not like that, okay? That's not agile, okay? And we focus on the working software rather than the comprehensive documentation. Deliverables. That means we will focus on anything that can be a deliverables, the working software. This is something that the customer want to see. We will focus on that, not the comprehensive documentation, right? But it doesn't mean that agile, we don't write any documentation. Not like that. We only focus on the just enough documentation. This is enough for the developers to understand what the feature is, what are we going to develop, and then all that, right? We will focus on the customer collaboration over the contract negotiation, okay? So that means we keep the interaction really well with the customer, maintain the relationship with the clients, that kind of thing, and we are responding to change over following a plan. All right, that's the last one. Okay, then I actually have this video. It is really good. I'm gonna open it now. Yeah.
So it was 2001. And a group of software visionaries gathered at a ski resort to share their experiences and figure out why so many software projects were failing. This wasn't just about documenting best practices. They knew the industry required a fundamental shift in values, and so the Agile Manifesto was born. A declaration of 4 bold value statements that became the basis of a new approach to software development and would change the industry forever. But what were those 4 values, and why should you care? Let's take a look. But first, it is important to point out that the Agile Manifesto ends by noting that all of the things mentioned are important, just that some things must be prioritized over others. Okay, here we go. Number 1, individuals and interactions over processes and tools. This doesn't mean throw processes and tools out the window. It simply means that a good face-to-face chat should trump rigid workflows and impersonal forms of communication. Number 2, working software over comprehensive documentation. Makes sense, right? But traditional software development often produced extensive documentation before a program was released for initial testing. Some documentation is good, but wouldn't it be better to have the program than a book describing it? Number 3, customer collaboration over contract negotiation. Sure, you'll want to start out with some initial guidelines, but instead of locking customers in a cage by defining the exact details of the project before it starts, teams and customers should collaborate to find the best solutions. And finally, number 4, responding to change over following a plan. Nothing ever goes entirely according to plan. So instead of sticking with something that isn't working, it's much more effective to make adjustments as your situation changes. Following the values isn't always easy, but when you build them into your team's processes, customers notice, and the payoff is huge. Which of the Agile values do you think is the most important?
Okay, thank you. Well done. And these are the Agile Manifesto, Agile values, right? And to implement the Agile methodology, there are 2 frameworks that are most popular at the moment. The first one is Kanban, and the second one is Scrum. Okay, so I'm gonna explain what is the difference between the Kanban and the Scrum. So Kanban is actually originally from Japan, and that's the wording, the term Kanban, and it is about visualizing your work and into the Kanban board like this. They really focus on the flow of the task rather than the what is going to be the deliverables over the sprint. Okay, Kanban doesn't have any sprint. They focus on the flow of the task only. Okay. They try to reduce the time taken to take a project from start to finish. What I mean is that these are the backlog. The Kanban board. This is how the Kanban board look like. There are 4 columns, 4 lanes. Okay, the first lane is the backlog. These are the things that we need to do, and to do is the lane that we are focusing on what we are doing at the moment that we need to do now. Okay, and ongoing, this is to do, and then what have been done, right? Okay, so Kanban board helps you to prioritize the task and to maximize the efficiencies within the team as well. Kanban is quite useful. Let's say you want to work in how can I say IT admin team. Okay, IT system admin. Let's say Monash eSolution. Okay, I have a request. Student have issue about 2-factor authentication. Another student have issue about course enrollment. Another student have issue about blah 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 blah. So these are the backlog that probably either Monash eSolution or the Monash Connect has within their team, right? And then each of the staff, they will need to prioritize. Okay, these are the things that we need to do, complete by today, and then they try to organize, arrange the work, assign the task one by one. Ongoing, these are the first thing that we need to do and try to complete it. They focus on the flow of the work, okay, flow of the task, rather than the what are we going to deliver within the sprint. Okay, make sense? For the Scrum, it is the framework that helps a team to work together to develop, deliver, and sustain complex products. Okay, so everything is divided within the time frame. Kanban doesn't have a time frame. Scrum has a time frame. Okay, if you look at this Scrum process, right? So we start from the vision. We everyone within the team, business analyst, client, stakeholder, product owner, Scrum Master, everyone come together, develop the product vision. What are we going to develop? Why? What are the values that we are going to bring to the team, to the customer, that kind of thing. And then once we know the vision, what are the things that we need to do, then we will prioritize. These are the features that we want to develop, right? As a user story, prioritize them within the sprint backlog, right? Scrum Master is the facilitator to facilitate the Scrum process, to make sure that the team is aligned with the Scrum process. And then for the Scrum process, it consists of multiple sprints. Each sprint lasts for 2 to 4 weeks. So within 2 to 4 weeks, they try to complete everything, deliver everything that I assign in the sprint backlog, right? These are the things that we need to complete within the sprint. Once they complete, they do then they can deliver to the client. Okay, this is the Scrum. The previous one is the Kanban. Okay, it is different. All right, so the details about the Kanban and the Scrum. no, sorry. The detail about the Scrum Agile Project Management, we will talk about that in week 4 as well, in more details. Okay. Any other questions? No? Okay. The last thing, right? This one is very interesting. Open source software development. When we work in a company, normally we work because someone asks you to do, but in the open source software development, it is totally different, okay? Because everyone is a volunteer, and then they just work collaboratively within the GitHub repository, whatsoever, right? And surprisingly, this kind of open source software projects, they are really successful. For example, Android operating software system within your mobile phone, that's also inherit from the Linux open source software system as well. The web browser, right? Look at the Mozilla Firefox, Google Chrome. These are the open source software development as well. Yeah. So the key point of the open source software development is that individuals generally work voluntarily on the open source software projects in their spare time. It's not like a contract; they don't get paid at all. Okay, so that's an open source software system. Okay, and there's no standard lifecycle model at all. But surprisingly, they have a clear process within the open source model. Normally, they use GitHub pull request, they apply code review, that kind of thing, to ensure that the code is of high quality. Okay, that's an open source software development. Okay, let's try to do some quiz together. I prepare a few questions to ask everyone. We're gonna use the flux.qa flux quiz. Let me see, where are we? Okay, can everyone access the flux quiz or not? Maybe yes. Can you type yes in the Zoom chat if you can? Thank you. Yes. Okay, so you go to flux.qa/ capital letter MT8NG2, this one. Okay, I'm gonna start the first question. Okay, 1, 2, 3, go. Uh-oh. Okay, we have roughly 20 people have answered at the moment. What is the primary goal of the software engineering? The first choice: to develop the software quickly, to develop software cheaply, to develop software efficiently and reliably within the budget constraint, to develop software with the most features. All right. So we have 153 students within the Zoom lecture at the moment. I'm gonna wait until over 100. All right. So to go to the Flux quiz, you just join flux.qa/mt8ng2. Okay, paste the link in the Zoom chat. 1 second. Okay, all right. So I'm gonna. Should I stop now? Okay, people still participate in the quiz. Maybe I will wait a few more minutes. Okay, all right, maybe I will stop. Let's see the answer. Okay, nearly everyone got the right answer. Okay, to develop software efficiently, reliably within the budget constraint. That's the actually primary goal of the software engineering, right? But in terms of the business, of course, maybe they want to deliver the most feature as much as possible, but it's not the primary goal of the software engineering. Okay. Yep. Next question. Yep. Next question. What is the waterfall model in software development? First, a linear and sequential approach, an iterative and incremental approach, a flexible and adaptive approach, a reactive and unplanned approach. Okay, all right, everyone. Anyone needs more time? Okay, maybe I will release the answer now. Okay. Yep. So, okay, all right. So basically, waterfall model, right? It is actually a linear and a sequential approach. That's the correct answer. It's not a reactive or unplanned approach at all. Definitely, it's not really flexible and adaptive. When the requirement was changed, later on in the stage of the software development, it is so hard. It's not really flexible at all for the waterfall model. Okay, is that an iterative and the incremental approach? Basically, waterfall is not incremental and it's not iterative at all. It has just only one iteration, one iteration. Okay, that's the waterfall model here. You know, let's say this is a 1 year process. You start from the requirement analysis, design, implementation, maintenance, and then all done. There's no loop back to the requirement again. But if you talk about the incremental software development, this is more like iterative and it is increment. And this is not waterfall, right? But I would call this is a several mini waterfall within the iteration, okay? Within one iteration, this is a mini waterfall. We start the specification, development, and validation, release, and then we start another iteration. Incrementally develop the piece of software. Okay. So that's why the correct answer should be the first one, a linear and sequential approach. There's no loop back to the first step at all. Okay. All right. Thank you, everyone. Next. Start. Yep. What is the primary goal of agile software development? First, to follow a strict plan and schedule. Second, to deliver a working software product quickly. Third, to focus on documentations and processes. Fourth, to prioritize customer collaboration over contract negotiation. What is the primary goal of agile software development? Okay, so I'm gonna release the answer now. Okay, we have reached 100 people. We still receive more answer here. Okay, maybe I will wait a few more minutes. 107, all done. Okay, all right, pause. 1, 2, 3, and let's see the result. Oh wow, okay. What is the primary goal of the agile software development? Let's take a look at one by one together, right? Sorry, excuse me. First, to follow a strict plan and schedule. Probably this is not the agile software development. What is the agile manifesto? Anyone remember this one? Okay, let's take a look at this one again. They focus on what is that? Responding to change over following plan, right? So that's why agile, we will not focus on the strict plan at all. So the first option is incorrect. Okay, to deliver a working software products quickly. Is this correct? Okay. What do you mean? My questions disappear as soon as the answer is given, and I only remain with the first question repeated twice. Oh, really? Okay. Maybe I will take a look. Yeah. So, okay, let's take a look at the second option, to deliver a working software product quickly. Is that the primary goal of the agile software development? Is that true? Maybe let's take a look at C. Yeah. To focus on documentations and processes. Probably this is this one clearly no, because we focus on what? Working software over the comprehensive documentation. Okay. So C clearly is not. Okay. D, to prioritize customer collaboration over contract negotiation. Yeah. So is it D dog? Yes. Is the third one customer collaboration over contract negotiation? So back to B, to deliver a working software products quickly. Partly yes, I think I would say either B or D should be the correct answer. Okay, yeah. So B boy, we focus on the working software products rather over the documentation. Okay, so in this case, I think either B or D. Yeah, they are fine. Yeah. Okay, all right. Next one. How many questions do I have? Start. What is the main benefit of using agile software development? It allows for a more predictable project timeline. It encourages a fixed scope and requirement. It focuses on detailed documentations and planning. It promotes flexibility and adaptability. ATT people have answer. I will try to aim for 100. Let's try to get 100. Okay, 4 more. Anyone? All right, pause. Okay, let's take a look at the answer. All right, okay. What is the main benefit of using Agile? The majority of the answer is the to promote the flexibility and the adaptability. Yes, that's the correct answer. Clearly, B and C, they are not correct because when we, based on the Agile Manifesto, we focus on what? Okay, working software products over the detailed documentation. So this is not the this is the incorrect answer. Okay. B, it encourages a fixed scope and the requirement. Agile is quite flexible, so this is the opposite answers of the D. So clearly B choice here, the choice B is incorrect. Okay. A, it allows for a more predictable project timeline. I'm not sure whether this is a benefit or not, right? Timeline is another thing, but the benefit here is that it allows you to adapt to the change, respond to the requirement change, that kind of thing. So that's the main benefit. But the timeline is another factor that I don't think Agile can control. Okay. Yep, makes sense. All right. Okay. Last question. What is the Agile Manifesto? What is the Agile Manifesto? Yeah. Is that a detailed project plan? Is that a set of values and principles for Agile software development? Is that a type of the software testing? Is that a document outlining the project timeline? Maybe one more minute. Yep. 5, 4, 3, 2, 1. I will pause now and then show the results. Okay. Yes, every student, not every, most of the students got the right answer. Agile Manifesto, right? Basically, it is a set of values and the principles for the Agile software development. It's not the detailed project plan at all. It doesn't describe what the features that we are going to develop. So it's not the project plan. It's not about the document outlining the project timeline. It doesn't set any timeline. So manifesto, if you go back to this one, check out the video. These are the 4 key values and the principles of the Agile software development. Individuals and interactions over processes and tools, working software over the comprehensive documentation, customer collaboration over the contract negotiation, responding to change over the following a plan. All right. I think, oh, actually I have one more question. Okay. Which of the following is not one of the Agile Manifesto values? Oh, I just said everything. No. Which one is not? Okay. The first one, individuals and interactions over processes and tools, working software over comprehensive documentation, following a plan over responding to change, customer collaboration over contract negotiation. Okay. Which one is not? Okay, is not. Yeah, you have read the Agile Manifesto before the class, so thank you. Okay. 5, 4, 3, 2, 1, yes. Let's see the results. Alright, which one is not? Which one is not? Yes, for the choice A, individuals and interactions over processes and tools. That's the Agile Manifesto values. Okay, that's the value. Working software over the comprehensive documentation, that's the value as well. Okay, customer collaboration over the contract negotiation, that's the value. But which one is not is the choice C. Okay, we focus on the responding to change over following a plan. Okay, all right. So that's the correct answer is the choice C. Which one is not? Okay, responding to change over following a plan. This should be the value, but following a plan over responding to change is not. Okay, make sense, everyone? Do you have fun? I think the quiz is all gone, is all done. We have finished. So I'm gonna open the floor to the questions and the answer. Yeah, any questions and the answer? Any questions before we wrap up the lectures? Any questions so far? Yep. Okay. Thank you. Okay. That question. What is the most common payment agreement with the client for agile development? Usually in waterfall, the project scope and requirement are clear at the beginning and development team can provide certain amount. However, in agile method, the overall development scope is not very clear and changes are being made constantly. How can the client estimate the development will be in the given budget, and what kind of processes should be in place to manage development and not going over the estimate budget? Okay, thank you for your question. Right, I would say that if this is the case, if I were a project manager, I would develop a contract as based on the man hours, based on the actual time spent, rather than the fixed contract, right? So I would just keep it open. So that means it really depends on the client now, whether they want the project to be overrun or not. So we leave that constraint to the client rather than taking it by ourselves. You know what I mean? Yeah. And most of the companies they use this model as well, based on the man hours rather than the fixed price contract. Yep. Okay. So another question. So we can choose our group during our allocated applied class this week? Yes, that's right. And I highly recommend everyone to come to the apply session to form the group. Okay, maybe I should click this one, apply session. So before you attend the class, try to subscribe to the Lucidchart. Register the user, register an account, and then we will do some activities as well. Let you know, we would like to know about you as well, why you want to enroll in the Fit 5136, what do you expect to learn. We would like to know your programming experience as well. And question 4, we would like to know between the Java and the Python, which programming languages you are most proficient. And so we will use this the answer to decide the assessment for. Okay. Yeah. And what do you think about the unit schedule and the learning content? Let us know as well. Yeah. And anything that you would like to let us know. What do you think about the lecture? Are you happy with the lecture so far? Everything? The past? Is there anything that I can improve? Please feel free to let me know as well. The next part is about the Lucidchart. How can we use the Lucidchart? Okay, to draw the UI, the class diagram, sequence diagram, that kind of thing. How to set up the Trello. I already create the tutorial video for that, and that's the part of the group selection. Okay, it tells you the step by step how to do the group self selection. I highly recommend you come to the apply session talk to your friends and try to form the group together. Okay, it will be a group of 3 or 4 students. Okay, yep, that's the step how to do the group. And we have Java programming quiz and the Python quiz as well. Okay, someone raise a hand. What is your question? 1 second. Do you want to speak? Let me see. Hello.
Hi, sir. Can you hear me?
Yes, I can hear you.
Okay, so I have an issue accessing the materials on AdStamp. So I do have access, and I click on that. The only materials that I see is the welcome email that you sent.
Ah, all right. So
and I can share my screen if you allow me, so I can show you what I'm seeing.
You need to go to the lessons tab. Do you see my share screen?
Now, my UI is totally different from what yours is like.
Oh, really? Okay.
Yeah,
Maybe...
if you allow me, I can share my screen.
Okay. What about this? Because the lecture is recording, maybe I will handle this offline. What do you think?
Yeah, that's okay as well.
Okay. All right. Yep. Thank you. Okay. Okay. Any other questions? If not, then I will just wrap up the lecture for now. Would there be any material regarding source control? I will try to publish them as soon as possible as well. Yep, thank you. Okay, yep, thank you so much everyone for attending the lecture. We have over 150 students today. Try to keep this number over the next 12 weeks. And I really enjoy the active participation from everyone. Thank you so much, and I will see you in the apply session. Yeah, bye-bye.